So this is condition for destructive interference. I should be minimum. Equation for I we got intensity is directly proportional to square of the amplitude. So we got the relation I equal to I1 plus I2 plus 2 root I1 I2 cos phi. That is the equation. In that cos phi, I equal to I1 plus I2 plus 2 root I1 I2 cos phi. In that, when phi is pi, 3 pi, 5 pi, etc. Cos pi, what is the value of cos pi? Cos 180 minus 1. So our intensity is minimum when cos phi is minimum. Cos phi is minimum. Which angle cos phi is minimum? Cos value, minimum value is minus 1. When cos is 0, when angle is 0, cos 0 is 1. That is the maximum value. But when 90, when we take phi as 90, cos 90 is 0. And when we take 180 degree, cos 180, that is minus 1. So minus 1 is there, 0 is there, plus 1 is there. In that minimum value is minus 1. So when phi takes pi cos 180, that is minus 1. Then next 2 pi we cannot take because 2 pi will be, cos 2 pi will be 1. So that is the maximum value that we cannot take. So pi is then next value we are getting minus 1 is 3 pi. Then 5 pi. Then 7 pi. Like that. Odd integral, odd numbers are okay, pi, 3 pi, 5 pi. So odd integral multiple of pi. Odd integral multiple of pi avana. N equal to 1, 2, 3. Then we get the condition for constructive interference. Okay, odd integral even integral multiple of pi ayalendayirikkum constructive interference. Odd integral multiple of pi ayalo destructive interference. When you corresponding path difference path difference and phase difference connecting a relation. Yesterday we have got this x and path difference. Phi and phase difference. തമ്മിൽ കണക്ട് ചെയ്യുന്ന റിലേഷനാണ് x equal to lambda by 2 pi into phi. Path difference x, phase difference phi. The connecting relation is x equal to lambda by 2 pi into phi. So lambda by 2 pi, in the place of phi we substitute this value 2n minus 1 into pi, we substitute it here. Pi and pi cancel and we get 2n minus 1 into lambda by 2. 2n minus 1 into lambda by 2. X equal to, therefore path difference equal to 2n minus 1 into lambda by 2. This is odd integral multiple of pi. When you give 1, what we get here? 2 into 1, 2, 2 minus 1, 1, lambda by 2. First we get lambda by 2. Then give 2, 2 into 2, 4, 4 minus 1, 3, 3 lambda by 2. Odd first lambda by 2. Next 3 lambda by 2. Next 5 lambda by 2. Like that. Odd integral multiple of half the wavelength. Odd integral multiple of half the wavelength. This is half the wavelength, lambda by 2. About odd integral multiple of half the wavelength. This condition of course problem path difference phase difference constructive destructive condition of course for getting destructive interference, the phase difference between the two waves is odd integral multiple of pi, or path difference between the two waves is odd integral multiple of half the wavelength. Okay, remember the equations. Okay, here you can see the same thing is explained here. When interference is constructive, cos phi is 1. Therefore, resultant amplitude of the resultant wave equal to root of a square plus b square plus 2ab, which is equal to root of a plus b whole square, which is equal to a plus b. R equal to a plus b. This is some important point that you should know. the resultant amplitude of the wave. Yesterday we got this condition, R is equal to root of S square plus B square plus 2AB. Cos phi is there, but cos phi is 1. That means constructive interference now. So intensity will be maximum. That happens when phi is equal to 0, 2 pi, 4 pi, etc. So we get the equation root of S square plus B square plus 2AB. This is root of A plus B whole square. So that can be written as A plus B. So in constructive interference, the amplitude of the resultant wave is A plus B, sum of the amplitude of the individual wave. The R max, R means what here? Amplitude of the resultant wave. What is the maximum amplitude? For constructive interference, that will be A plus B. A means what? Amplitude of the first wave. B means what? Amplitude of the second wave. So maximum amplitude happens when we add both A plus B. So minimum will be A minus B. And we also know intensity maximum is directly proportional to square of amplitude maximum. I max is proportional to A plus B whole square. R square is A plus B whole square. Intensity is proportional to square of the amplitude. Amplitude is A plus B. Square of the amplitude is A plus B whole square. So I max is equal to K into, see proportionality sign is changed into equal to sign K into A plus B whole square. When interference is destructive, what happens? Cos phi equal to minus 1. So what is the formula for R? Root of S square plus B square plus 2AB into minus 1. Cos phi is minus 1. So we get R equal to root of A minus B whole square. So we got the difference of amplitude of the individual waves. Difference. Destructive interference, the resultant amplitude is difference of the amplitude of the individual wave. So R minimum is equal to A minus B. Therefore, I minimum is directly proportional to square of the amplitude. This is amplitude, square of the amplitude. What is square of the amplitude? A minus B whole square. I minimum is equal to some constant K into A minus B whole square. So I max we got, I minimum we got. Then dividing we get I max by I minimum. What is it? K and K get cancelled. A plus B whole square by A minus B whole square. Very important for doing problem. This formula also important. I max by I minimum equal to A plus B whole square by A minus B whole square. When B equal to A, both the waves are having same amplitude. What is R max? A plus B. A plus A, 2A. What is R minimum? A minus B. A minus B equal to A, A minus A equal to 0. Therefore, I minimum is 0. A minus A equal to 0. So, minimum becomes 0, completely 0. Maximum, it is its maximum value, A plus A, but minimum becomes 0. That means the bright band will be perfectly bright, but the dark band, that is completely dark. So, if there is a difference between A and B, some intensity of light will be there in that region. Some intensity, it will not be completely dark. Some intensity will be there. So, but when both are equal, both the waves are having same amplitude, that dark region, that will be perfectly dark. ചില സമയത്ത് നമ്മൾ പറയും ഭയങ്കര ഇരുട്ടെന്ന് പറയുന്നത് ഈ കറുത്ത വാവിനൊക്കെ എന്ന് പറഞ്ഞ മാതിരി ഡാർക്ക് എന്ന് പറഞ്ഞാൽ ഭയങ്കര ഡാർക്കായിരിക്കും. ഇനി അതല്ല അല്ലാതൊരു ഡാർക്ക്നെസ് ഉണ്ട്, ചെറിയൊരു ലൈറ്റ് കൂടിയിട്ടുള്ള ഡാർക്ക്നെസ് ഇല്ലേ, കംപ്ലീറ്റ് ഡാർക്ക് അല്ലാണ്ട് അതുണ്ട്. പക്ഷെ എ ഈക്വൽ ടു ബി ആയി കഴിഞ്ഞാൽ ഡാർക്ക് ഫ്രിഞ്ച് എന്ന് പറഞ്ഞാൽ അത് കംപ്ലീറ്റ് ഡാർക്ക് ആയിരിക്കും, ഒരു ലൈറ്റ് പോലും ഉണ്ടാകും തീരെ. അപ്പോൾ കോൺട്രാസ്റ്റ് വിൽ ബി വെരി ഗുഡ് കോൺട്രാസ്റ്റ് ആയിരിക്കും, ബ്രൈറ്റും ഡാർക്കും തമ്മിലുള്ള കോൺട്രാസ്റ്റ് നന്നായിരിക്കും. അപ്പോൾ അതിനുള്ള കണ്ടീഷനാണിത്, രണ്ട് വേവ്സിൻ്റെ ആംപ്ലിറ്റ്യൂഡ് ഓൾമോസ്റ്റ് ഈക്വൽ ആവുക. So, the dark fringes will be perfectly dark and the contrast between bright and dark interference fringe will be best. അപ്പോൾ ബെസ്റ്റ് ഫ്രിഞ്ചസ് കിട്ടാനുള്ള ഒരു കണ്ടീഷൻ കൂടിയാണിത്. both the waves, if they are having almost the same amplitude, we get a very good contrast in the fringe. Fringes, and I showed you now the fringes, dark green color fringe, the dark color fringe, like that. So condition for getting that contrast, very good contrast between the bright and dark. What is it? Amplitude must be same. Okay, next. So we studied now the condition for constructive and destructive interference and some other formula for doing problems. We have to study these formulas also, because usually problems ask from this part, and if you know the equation, it will be easy for you. Resultant intensity equation I1 plus I2 plus 2 root I1 I2 cos phi. If I1 equal to I2, both the waves are having same intensity. Let us take that I0. Let us take that as I0. Therefore, IR is equal to I0 plus 2 into root of I0 into I0. What is root of I0 into I0? Root of I0 square into cos phi. Then I0 plus I0, 2I0. Plus 2 into root of I0 square is I0. So 2I0 cos phi. In both the factor there is 2I0, so you can take it outside. 2I0 into 1 plus cos phi. 2I0 into 1 plus cos phi. And this 1 plus cos phi we can write as 2 into cos square phi by 2. How we got that step, that is explained here. So for doing problems, you just remember this formula. Just remember this formula. And that is 4I0 cos square phi by 2. Resultant intensity. When both the waves are having same intensity, resultant intensity's formula is this. Both the waves are having same intensity. Resultant intensity of the wave is 4I0 cos square phi by 2, and 1 plus cos phi is written as 2 cos square phi by 2. That step I have written here. Step actually not important. You can just directly write this. 1 plus cos phi equal to 2 cos square phi by 2. For that you should remember this. Otherwise you have to derive all this. How you are doing problem, just remember this formula, 4I0 cos square phi by 2. So the best method to learn this formula is every day. See, we are taking 1 or 2, not 1 or 2, 3 or 4 or 5 or 6 formulas we are taking, and those formulas you write in a chapter or in a book itself. 1 page you take and write that, and you keep that in a study table, in your study table. And just when you go to that side, this side, and always you look that, when you look that formula, it will be by heart to you, like that. Always in your site, you keep that paper with that formulas, so that you can remember. When you go to that side, you are seeing that formula. When you go to this side, you are seeing that formula. So every time you will see that formula, and it will be by heart. Either keep on the wall or on the study table, always keep. So you can remember all these formulas easily. Like that. So steps, I will explain the step. Cos square, this you know, cos square phi plus sin square phi equal to 1. That you know, everybody know. Then we also know cos of A plus B equal to cos A cos B minus sin A sin B. So when phase difference is phi for both the waves, cos phi plus cos phi equal to cos phi A, B are equal now. A and B are equal. So you can write phi here, A, here also sin phi. So this can be written as cos square phi minus sin square phi. Cos 2 phi equal to cos square phi minus sin square phi. And from 1, what we can write, sin square phi is 1 minus cos square phi. Putting 3 in 2. this equation you put in this one. That means in the place of sin square phi, you write 1 minus cos square phi. So cos square phi minus 1 plus cos square phi. So this and this cancel, we get not cancelling. So cos square plus cos square phi, that is 2 cos square phi minus 1. So cos 2 phi equal to 2 cos square phi minus 1. Therefore, 2 cos square phi equal to 1 plus cos 2 phi. Okay. Then when phi equal to phi by 2, what we get? Phi equal to phi by 2, cos phi equal to 2 cos phi by 2 minus 1. Therefore, 1 plus cos 1 plus cos phi equal to 2 cos square phi by 2. 1 plus cos phi we got 2 cos square phi by 2. That is written here. 1 plus cos phi equal to 2 cos square phi by 2. So find what is the final answer? Resultant intensity is 4I0 square phi by 2. So remember that formula for doing problems, application questions. Next, condition for sustained interference pattern. What is sustained interference pattern? The pattern in which maximum and minimum on the screen do not change with time is called sustained interference pattern. See that will not vary. Maximum and minima will not vary with time. The pattern, yesterday I showed one pattern, no interference pattern, that green color fringe, then a dark region, again a green color fringe, like that. So that pattern in which maximum and minima on the screen do not change with time is called a sustained interference pattern. And what are the conditions needed for that, for getting a sustained interference pattern? Two sources should emit waves of same frequency or wavelength. That means coherent source. That must be coherent. Two light sources must be coherent. That is written here. Okay. Same frequency, same wavelength, then it will be coherent. Okay. For better contrast amplitude, that is we have explained. Both the amplitudes are equal, very good contrast we get. Our interference pattern will be very good, better fringes will be obtained. Then sources should be narrow, laser beam like that, such a beam you have to use. They should be narrow and emit waves in the same direction. They should emit waves in the same direction. Then distance between the source must be small, but distance between source and the screen is at a large distance. Distance between two slit must be very small, but distance between slit and the screen is large. About 1 meter is there. Distance between two slit only micrometer. Understand? So very small distance. But distance between slit and the screen, large distance. 1 meter, 2 meter, like that distance. So these are the conditions for getting a sustained interference pattern. Next, interference and energy conservation. So in interference, what we have seen? Redistribution of light energy. Some part appear to be very bright, some part appear to be dark. The same, see, if you keep a paper, on the paper we are seeing all these phenomena. One part appear bright, another part appear dark. So that phenomena happen. That means energy is actually redistributed. Some part energy is lost, light energy is lost, and that energy is gained at the other part. Actually, here there is no destruction of energy. In destructive interference, that doesn't mean the destruction, that energy is lost there. Actually, redistribution is taking place. Redistribution. Where energy is lost is gained in the other part. So when you take the average value, that remains same when interference or not interference. That is what we have to show it here. So in interference pattern, what we have seen? The some part appear, if you take the interference pattern on a screen, some part appear bright, some part appear dark. Redistribution of light energy take place. What is the reason? Superposition of the waves from two coherent sources. Superposition of the waves from two coherent sources. So we have to show it is also according to energy conservation. What is energy conservation? Energy can neither be created nor be destroyed. It can only be transferred from one body to other or transformed from one form to other, like one form to other, like one body to other. We can transfer. Energy is always constant. Okay, total energy is always constant. In interference pattern, what is the maximum intensity we got? I max equal to K into A plus B whole square. And I minimum equal to K into A minus B whole square. This we have derived. What is average of these? Average, take average. Add these two, divide by 2. Add these two, divide by 2. So we have to add this A plus B whole square. A square plus 2AB plus B square. A minus B whole square. A square minus 2AB plus B square. Then what will we get in the numerator? 2AB plus 2AB minus 2AB cancel. Here A square is there, then here plus A square is there, but 2A square one. Then here 1B square is there, again here 1B square is there, 2B square. But 2A square plus 2B square. So you can write as 2 into A square plus B square whole divided by 2. This is the average intensity. We have determined average value I max plus I minimum by 2. That's equal to K into A square plus B square. So this is what happens when interference takes place. I max plus I minimum by 2, that is the average intensity. And if there were no interference, what is the intensity? Let us see. I equal to I1 plus I2. No interference. Two sources of light are there. What is the resultant intensity? Maximum is not there, minimum is not there, only uniform distribution of light energy is there. So you just add the intensity of the two waves, Ka square plus Kb square, that is K into A square plus B square. So you see, both the equations are same. When you take average value of the intensity during interference, we get K into A square plus B square. If there were no interference, what is intensity? K into A square plus B square. That means energy is not lost. The energy is conserved. The dark region energy is lost, but it is gained in the bright region. So the average intensity is same. So it is in accordance with the energy conservation. Average energy in interference pattern is same. Okay. It is accordance to the energy conservation. This the energy lost at the destructive interference is gained at the constructive interference. No energy is created or destroyed. Thus, principle of conservation of energy is being obeyed in the process of interference. As a 2-mark question that asked, show that interference is in accordance with the energy conservation. So you have to do all these steps. Find the average during interference, find the intensity when there is no interference, and show that both of them are equal. That means it is in accordance with the energy conservation. Next is a very important derivation. Fringe width of the fringe. Interference pattern, the width of the fringe. I will show you the figure again. What is the width of the fringe? Yes, this is the interference pattern observed on the screen. A single slit, Young's double slit experiment. Young's double slit, double slit experiment. Young means scientist. Which year he performed this experiment? 1801, 18th century. So you can see a single source of light, wavefront is coming from it in the form of crest and trough, and when it is passed through the two slits, same source of light is passed through the two slits, division of the wavefront take place here, and they act as coherent sources, and superposition of the wave is taking place here, and at the place of constructive interference we get maximum intensity. Central one is a bright region, and then at the place where destructive interference takes place we get minimum intensity. Again that is constructive interference, then destructive, constructive, like that alternate. Bright and dark fringes are obtained. So central one is always bright. This is the central one. See, this is the central line. We get the central bright fringe. Then next dark fringe. Next bright fringe, like that. Here also dark, bright fringes are obtained on the screen. This is the interference pattern. So the fringe width means this width of the fringe. This is the width of the fringe. And the bright region etra thickness and width. Width. Dark fringes are also having the same width. Within the fringe width, the distance between two minimas. The minimum distance between two minimas on either side of this fringe. രണ്ട് മിനിമം തമ്മിലുള്ള ദൂരം അതാണ് ഒരു ബ്രൈറ്റ് ഫ്രിഞ്ചിന്റെ വിഡ്ത്ത്. അതല്ലെങ്കിൽ രണ്ട് മാക്സിമം തമ്മിലുള്ള ദൂരം ഡിസ്റ്റൻസ് ബിറ്റ്വീൻ ടു ബ്രൈറ്റ് ഫ്രിഞ്ച് അതാണ് ഡാർക്ക് ഫ്രിഞ്ചിന്റെ വിഡ്ത്ത്. വിഡ്ത്ത് ഓഫ് ദ ഡാർക്ക് ഫ്രിഞ്ച് ഇസ് ഡിസ്റ്റൻസ് ബിറ്റ്വീൻ ടു ബ്രൈറ്റ് ഫ്രിഞ്ചസ്. ഒരു ബ്രൈറ്റ് ഫ്രിഞ്ചിന്റെ പൊസിഷൻ നമുക്ക് കാൽക്കുലേറ്റ് ചെയ്യാം ഇക്വേഷൻ വെച്ചിട്ട്. അത് ഇനി വരാൻ പോകുന്നുള്ളൂ, ഇക്വേഷൻ വരാൻ പോകുന്നുള്ളൂ കേട്ടോ. അപ്പൊ ഫസ്റ്റ് ബ്രൈറ്റ് ഫ്രിഞ്ച് ഇക്വേഷൻ അറിയാം, സെക്കൻഡ് ബ്രൈറ്റ് ഫ്രിഞ്ച് ഇക്വേഷൻ അറിയാം. അപ്പോൾ മൈനസ് ചെയ്യാം. ഫസ്റ്റ് സെക്കൻഡ് ബ്രൈറ്റ് ഫ്രിഞ്ചിന്ന് ഡിസ്റ്റൻസിൽ നിന്ന് ഫസ്റ്റ് ബ്രൈറ്റ് ഫ്രിഞ്ചിൻ്റെ ഡിസ്റ്റൻസ് സബ്ട്രാക്ട് ചെയ്ത് കഴിഞ്ഞാൽ ഇതിൻ്റെ വിഡ്ത്ത് കിട്ടും. ഓക്കെ, അപ്പോൾ ദാറ്റ് മെത്തേഡ് വി ആർ ഗോയിങ് ടു ഡു. ഓക്കെ, fringe width, we are finding fringe width. Understood? I think you understood the width of the fringe. And you can see in interference bands almost same width is there. For the dark fringe or bright fringe, they are having the same width. Not like diffraction. In interference, the fringes are of equal width. Okay, the derivation you will see that width of the fringes are same. Now we can do that derivation. Only 5 minutes more. Yes, this is the experimental setup. Young's double slit experiment. So here is the monochromatic source of light. A and B are two slits through which the wavefront passes. Superposition of the waves take place, and here on the screen we get the interference pattern, and here we are finding the path difference. Okay, and you consider the point C. A and B are the two slits. This is the middle point. We have to mark point over here. So this from the middle point of the slit to this point C. See, this is the perpendicular drawn. And here also you draw a perpendicular distance AE. Here also you draw a perpendicular BF. Perpendiculars are drawn. For what? We have to find the path difference. I'll ask a question. All of you listen well. What is the path difference between the two waves coming from A and B and reaching this point C? See at the middle point of the screen. So that means corresponding to the middle of the two slits. What is the path? Is there any path difference? The wave from A reaches here and the wave from B reaches here. What is the path difference? What is the path difference? I'll ask to Ismail. What is the path difference between the two waves coming from A and B and reaching the point C? Ismail. What is the path difference between the two waves coming from A and B and reaching the point C?
0.
Very good. They are having equal length, so path difference is 0. When path difference is 0, will we get constructive or destructive interference? Path difference 0. Center 1. Will it be bright or dark? Path difference 0. Can you tell? Path difference 0. Will it be bright or dark? Central fringe. But then teacher figure ഒക്കെ കാണിച്ച് എക്സ്പ്ലെയിൻ ചെയ്താണ്. സെൻട്രൽ 1 ബ്രൈറ്റ് ആണ് ഡാർക്ക് എന്നാണ് ടീച്ചർ പറഞ്ഞത്. സെൻട്രൽ ഫ്രിഞ്ച് ഇസ്മയിലും ഉണ്ടാണ്ടായി. ഏത് പാർവതി?
ഡാർക്കാണോ ടീച്ചർ?
ഡാർക്ക് എന്നാണല്ലേ ഇപ്പൊ തന്നെ പറഞ്ഞത് ഞാൻ. സെൻട്രൽ വിൽ ബി പാത്ത് ഡിഫറൻസ് 0 ആയാലും ബ്രൈറ്റ് ഫ്രിഞ്ച് അല്ലേ? ഇപ്പൊ തന്നെ കാണിച്ചില്ലേ സെൻട്രൽ ബ്രൈറ്റ് ഫ്രിഞ്ച് ആണ്. അതിലാണ് ആ കണ്ടീഷൻ നമ്മൾ പഠിച്ചത്. വെൻ പാത്ത് ഡിഫറൻസ് ഈസ് എൻ ലാംഡ വി ഗെറ്റ് എ ബ്രൈറ്റ് ഫ്രിഞ്ച്. പാത്ത് ഡിഫറൻസ് അതിൽ n 0 ആയി കഴിയുമ്പോൾ എന്തായി? n ലാംഡേന് n 0 ആയി കഴിഞ്ഞാൽ n എന്ന് പറഞ്ഞാൽ ഫസ്റ്റ് ഫ്രിഞ്ച് സെക്കൻഡ് ഫ്രിഞ്ച് അങ്ങനെ n 0 ആയി കഴിയുമ്പോൾ 0 ആയില്ലേ? പാത്ത് ഡിഫറൻസ് 0 ആയില്ലേ? അല്ലാണ്ട് പാത്ത് ഡിഫറൻസ് n ലാംഡ ആകുമ്പോഴാണ് ബ്രൈറ്റ് ഫ്രിഞ്ച്. അപ്പൊ n 0 ആയി കഴിയുമ്പോൾ പാത്ത് ഡിഫറൻസ് 0 ആയി, അപ്പൊ ബ്രൈറ്റ് ഫ്രിഞ്ച് ആയിരിക്കും കേട്ടോ. ഇപ്പൊ ബ്രൈറ്റ് ആണ്, സെൻട്രൽ വൺ വിൽ ബി ബ്രൈറ്റ്. പിന്നത്തതാണ് ബ്രൈറ്റ് ആണോ ഡാർക്ക് ആണോ എന്നറിയാൻ നമ്മൾ പാത്ത് ഡിഫറൻസ് തന്നെ കണ്ടുപിടിക്കണം. അപ്പോൾ ഹിയർ യു ടേക്കൺ എ പോയിന്റ് പി. ടേക്ക് എ പോയിന്റ് പി. See, this is at a distance capital D. Distance between the two slit and the screen capital D. Distance between the two slit small letter d. And the path of the wave is shown here with blue colored rays. It is shown. Waves are not shown. Only rays of light are shown. The wave from A reaches P by traveling a distance AP. APM. The wave from B reaches P by traveling a distance BP. What is the path difference? Which is longer? BP is a longer path compared to AP. So there is a path difference. BP is longer. So there is a path difference. How will you find path difference? BP minus AP. BP is longer. BP minus AP will give the path difference. Then how will you find the BP? Path difference you have to find. When path difference is n lambda, it is a bright field.